So you're on your way to becoming a pharmacist, which means you'll be taking individual ingredients and compounding them into actual medicine. But, sometimes those ingredients, they just don't want to play nice. That's exactly what we're talking about today. Mastering physical incompatibilities. This is a huge deal for compounding, and you guessed it, a major topic for your exams. So let's get into it. Okay, picture this. You're in the lab. You've got two perfectly dry, solid powders. You mix them together and wait, what? You've got a puddle where your powders used to be. You didn't add any heat, no water, nothing. That, my friend, is not magic. It's a classic example of physical incompatibility, and it's something you've absolutely got to understand. So here's our game plan. First up, we're going to define what a physical incompatibility even is. Then, we'll get into the usual suspects. Stuff that won't mix or dissolve. We are definitely going to solve that weird puzzle of the liquefying powders. And then, the most important part, we'll open up the pharmacist's toolkit to see how to fix all this before we wrap it all up with a quick recap of the must-knows for your exams. All right, first things first, let's build a solid foundation. What are we actually talking about when we use the term physical incompatibility? The number one word to remember here is visible. This isn't some invisible chemical reaction happening on a molecular level. Nope. This is a change you can literally see with your own eyes, a change that makes the final product totally unacceptable. And think about why. If your medicine isn't uniform, how can you possibly guarantee a consistent dose? You can't. And that's a huge safety problem. These are pretty much the big four you're going to run into. You've got immiscibility and insolubility, which are all about things just refusing to mix properly. Then there's precipitation, where a solid just unexpectedly crashes out of a solution. And of course, liquefaction, that bizarre phenomenon where solids decide to become a liquid. We're going to break down each one. Okay, let's tackle our first two troublemakers, immiscibility and insolubility. Honestly, these are probably the most common headaches you'll face when you're compounding liquids. So what's the difference? It's simple, really. Immiscibility is when two liquids won't mix. The classic example is oil and water, right? They're always going to separate. Insolubility, on the other hand, is when a solid won't dissolve in a liquid. This is a big deal with something called indiffusible solids, which are too heavy to even stay suspended on their own. And here's a perfect real-world example. If you were told to make something with castor oil and water, and you just poured them together, you'd end up with this useless mess of separate layers. A patient could never get the right dose from that. It's a very practical problem that demands a real pharmaceutical fix. All right, let's get back to that weird one, the one that seems to break the rules. This is where your physical chemistry knowledge really gets to shine, and let me tell you, it's a favorite for exam questions. So here's the secret. It's called a eutectic mixture. It sounds complicated, but the idea is pretty cool. A eutectic mixture is just a blend of substances that melts at a lower temperature than any of its individual parts. So even though menthol and camphor are both perfectly solid at room temp by themselves, when you mix them, their combined melting point suddenly drops below room temperature. And poof, they turn into a liquid. So the process itself is what matters. You start with two separate, solid powders. The very act of mixing them, of titrating them, forces those particles into close contact. That's when the eutectic effect takes over, and suddenly you've got a liquid. Understanding why this happens is the absolute first step to knowing how to stop it. Okay, so we've identified the problems, but let's be real. A pharmacist's job isn't just to point out what's wrong, it's to make it right. So this next section is your toolkit. This is how you create preparations that are stable, effective, and, well, elegant. Here are the main strategies you've got. Sometimes it's as simple as changing the order you mix things. Other times, you need to call in a specialist, a specific agent to help out. The whole game is about matching the right solution to the right problem. Let's circle back to our castor oil and water problem. To fix that immiscibility, you bring in an emulsifying agent. Think of this agent as a mediator. It has a part that likes oil and a part that likes water, so it can bridge that gap between them and create a stable, uniform emulsion. Problem solved. And what about those stubborn solids that won't dissolve, like zinc oxide and a calamine lotion? For this job, you need a suspending agent. What this does is it makes the liquid a bit thicker, increasing the viscosity. That slows down how fast the solid particles settle, making sure the patient can get a uniform dose after a good shake. Now for our liquefying powders. The fix for this is actually pretty clever. The trick is to keep them physically separated. So what you do is you mix each of the problem powders, like the menthol and the camphor, with a bulky inert powder first before you combine them. This powder acts like a physical barrier, keeping the solids from getting too close and forming that liquid mixture. Phew, okay. We have covered a ton of ground. Now let's zoom in and condense all of this into the super high yield points, the stuff you absolutely need to lock in for your exams. This slide right here, this is your study guide. If you walk away with anything, let it be this. Immiscibility, those liquids that won't mix, you fix it with emulsification. Insolubility, those solids that won't dissolve, you grab a suspending agent. And liquefaction, that eutectic mixture, you use an adsorbent powder. Know the problem and know the specific tool to fix it. That's the key. Because at the end of the day, understanding physical incompatibilities is so much more than just about passing an exam. It's about being a competent professional. It's how you make sure that every single preparation you compound is safe, effective, and stable for your patients. It's a fundamental part of the art and science of being a great pharmacist.